Hello, welcome to Astronomers Without Borders Facebook Live special for Global Astronomy Month. I'm so happy that you could join us today. Wherever you are watching us, welcome, whether it's morning, daytime, or maybe late at night. We're really very thankful for you to join us for a few precious moments out of your day. Global Astronomy Month, this is our 12th edition that we're holding the world's largest astronomical festival. And this is an amazing time of the year because people from all walks of life are coming together and sharing the night sky. Our shared heritage of the night sky belongs to everyone, and everyone has access to it, of course. And during Global Astronomy Month, you get to experience some of the wonders of the universe shared by our global community. Astronomers Without Borders is here to build and cultivate community using, of course, astronomy and the passion that we all have for the night sky. We're in over 140 different countries, over 12,000 members strong, and growing every day with people just like you. And I encourage you to visit our Global Astronomy Month calendar. You'll find that on our website, gam-awb.org. You can visit that, and the GAM calendar will show you a whole list of events that run throughout the month of April. We've got observing events. We've got, of course, a lineup of special Facebook Lives, just like today, and concerts, astronomical artwork, and, of course, we have special kind of observing that we do with robotic telescopes as well. So you do need to tune in for that. And of course, we have podcasts. Thanks to our partners at Cosmic Savannah in South Africa. Do check that out every week. And we have special photo campaigns as well. And one of them I must talk about, since we are talking about Mars today, is our Beauty Without Borders campaign. Now, this is the fourth edition that we're running this global photographic campaign. We're basically putting a call out to everyone, all of you around the world. Maybe you have a smartphone or a DSLR camera, and we're inviting you to take a photograph of the coming conjunction between Mars and the moon. And we've got all kinds of information on tips and tricks on how to take a photograph, how you can capture this beautiful close encounter between Mars and the moon that's happening this Friday and Saturday, the 16th, 17th of April. We're very excited to be partnering with the timeanddate.com website. Of course, our perennial favorite to know when and where things are happening in the night sky, or on your calendar. Always those time zones can be tricky to know where and when things are happening. Timeanddate.com have you covered there. So we've got them partnering with us on this wonderful campaign. And we've got sky charts, of course, for you to learn where and when to see in your skies the Mars encountering with the moon, and how you can take your own photograph. And then when you do, we ask you to share them with us and upload them on our submission form right here. You can upload your photographs to us, and we will be taking those photographs and creating an animation out of it that will showcase the differences globally of how this celestial event looks from different parts of the world. It'll be fascinating stuff. I encourage you to do that. We'll put a link to this Beauty Without Borders campaign on in the comment section below, so you won't miss a thing. So do check that out on our website. You can go to astronomerswithoutborders.org. We'll have all the links in the comment section below. So, of course, Mars with the conjunction with the moon, fascinating stuff. And of course, it's in the news so much. It's a huge buzz around the world. Why? Because NASA, of course, has sent it's a giant 1-ton rover, Perseverance, that landed in February, almost 2 months ago now, and has started exploring the surface of Mars. And it has a little hitchhiking companion basically a 4-pound little drone helicopter named Ingenuity. And everyone is excited because we're on the verge of a historic milestone in space exploration of launching into flight, taking flight for the first time, a vehicle on another world, a flight of another world. It's incredible. And I've got a little video here just to whet your appetite on an animation that NASA put together of what we can expect perhaps in the next few days or within the week's time. So check this out. It's really exciting stuff. So there's going to be a lot of excitement in the next week or so once this little drone helicopter takes flight, and the views from it with the cameras on board it and the rover will be fantastic. And by the way, the chat room is open. We've got comments and folks sharing their locations everywhere around the world. We've got Kieran from New Jersey, United States, Suna from Turkey saying good evening. We've got Mark from Titusville, Florida, Space Coast. Welcome, Mark. We've got Astronorm from the Philippines, Sadaya from Victoria, Australia, Hina from Space India, and Olienka from AWB Nigeria. So nice to see you, Olienka, and all the good things that you're doing with AWB there in Nigeria. So proud, so proud. George, our national coordinator from Cyprus, is joining us. Welcome to the broadcast, George. Byron from Tulsa, Oklahoma as well. And Raul from Belgium. Welcome. And so many more of you are joining, coming on. Kazuya from Japan. Welcome. Also, our national coordinator, Kazuya Ayani, who's helped put together, big shout out for you for helping us with our Beauty Without Borders campaign. Kazuya is our national coordinator for that. Fantastic. So welcome, everybody. Exciting times. And without further ado, I have to introduce you to our guest today. This gentleman, Dr. Christopher Riley, is a writer, filmmaker, director who has a passion for space exploration, for nature at large, and has produced such amazing documentaries that have run on channels like National Geographic, Smithsonian, and probably documentaries that you've grown to love over the many years that he's been working in the industry. And he's here today to share with us a new, very interesting project. I'm really excited to talk to him about and listening to what this project about, which involves the planet Mars in a very innovative way and comparing it to our blue marble here, the little planet we call Earth. So without further ado, let me introduce you to Christopher Riley. Hello.
Andrew, hi. Can you hear me okay?
I can hear you. So, Christopher is talking to us from London, England. How are you?
Well, I'm good. I'm good. It's almost as cold as Mars here today. My feet have been freezing all day. I don't envy Perseverance at the moment, or the poor little helicopter, because it's the drone, because those nights are really harsh, aren't they?
It's you know what is it's incredible to think that we've created this technology. We've never really tried it on another planet, and here this could really be a game changer. I'm really curious. Before you get into your presentation, Chris, I'd love to hear your take on what do you think about this little what could this little helicopter mean for us in terms of Mars exploration?
Well, I mean, I think at this stage it's technology proving test flight, this, isn't it? Really, and I guess it was what it symbolizes. It's extraordinary, really, when you think about how far we've come from those early first flights past Mars in the 60s, where we got just a few black and white pictures back, through to making a heavier than air powered flight on the surface, not that many decades later. I mean, you wonder where this is all going to lead. You kind of hope that it culminates in a footprint, or at least that's another step towards the next chapter. But right now, it's just exciting to hope that Ingenuity works and we get some aerial shots of that landing site with Perseverance there below. It's going to be amazing. Fingers crossed for next week, hopefully.
Yeah, I mean, this really literally means that we're going to have a brand new perspective on Mars, won't it?
Yes, of course. I mean, what's already appeared clearly from Perseverance's pictures that have been released is that new perspective, even on landing, whether you're looking down on the rover on the sky crane as it approaches the surface, or up at it as the cables are cut and the delivery mechanism flies away. I mean, we've already got this new perspective on Mars from just seeing those images. So I mean, that's only going to get even more miraculous and exciting, I think, in the coming weeks, as we hopefully get some of these test flights from Ingenuity as well. It will be a very different viewpoint, I think, that will make it feel almost even more like we're physically there ourselves, and that can only be thrilling and exciting. Okay, well, without further ado, in case the connection fails again, let me get started. Thanks, Andrew. So I was born at the end of the 60s. I'm a child of Apollo, if you like. This is a picture of me about 2 and a bit, talking to Neil and Buzz from, coincidentally, a house we lived in at the time in York, near York in the UK, called the White House. So there we go. I wasn't with Nixon, but that was me about the time Neil and Buzz were on the moon. I was about 10 years old then by the time Star Wars came out, a sort of decade or so later. For me, those realizations that George Lucas had kind of created of these exoplanets were just breathtaking. I'm sure anyone else of my generation remembers those curtains pulling back a little bit further in the cinema, and suddenly there was this extraordinary widescreen vision of these other worlds, which just made them feel really real. I already had photographs of the surface of Mars from the Viking landers on my bedroom wall by then, and I just enchanted by the thought that you could go out in the back garden. My dad had a great pair of binoculars and a love of astronomy as well, and he would point out Mars over a cherry tree in the back garden, and we get the binoculars out and have a look at it, and then I could go back, and in my bedroom there was a picture from the surface. And I think in my head, this was all kind of mixed up in one sort of place, with Star Wars and real planets and these fictional exoplanets. And we knew of no other planets outside of the solar system then, of course, as well. But as we were pushing out further and further, of course, Voyager left the same year as Star Wars came out. And I got really excited. I couldn't spell Voyager, but in my diary at that time, there we are on the 3rd of March, I wrote that Voyager 1 and Voyager 2 sent back some lovely pictures of Jupiter. I'm not sure I got the dates or the sequence of the spacecraft quite right there, but I was really taken by all of this. So the following decade, as the Voyagers carried on out into the outer solar system, I started a geology degree at the University of Leicester, and used Voyager data to create maps of the moons of Uranus as part of my undergraduate work there. I was really kind of hooked on this subject, I suppose. And by the time the Voyagers passed Neptune in 1989 and took this picture as they were heading out of the solar system, looking back at Triton and Neptune there, beautiful crescents, both of them, I was embarking on a PhD using space shuttle data from a Space Lab mission, one of the early shuttle flights, Columbia flights. And I was interested in the data from something called their metric camera, a German camera that was flown on board Space Lab, a European Space Agency instrument, and it took beautiful high resolution stereoscopic imagery of the Earth. And I was interested in this particular region where North Africa meets Europe, right on the Straits of Gibraltar, which you can see there just on the left hand side, in this kind of quirky view of the straits there. And I was using this this metric camera imagery, stereoscopic imagery of these mountains in the south of Spain, the Sierra Nevada, in order to create these digital terrain maps, very common these days, but in those days they were difficult to produce. And then I was using those to work out something of the plate tectonic history of Africa crashing into Europe. It was great fun, and I spent a lot of months walking up and down around the mountains, ground truthing what I was looking at from the space shuttle data. A few years after that, then I got my dream job at the BBC, working on a show called Mars to Clive Anderson, a comedian in the UK, and presenter, occasional presenter. And he was hired to kind of present this show, which was going to cover the Mars Pathfinder landing. So this was 1997. It was 21 years or so since the Vikings had successfully touched down and sent back those pictures, and everyone was really excited to see what might be on show. One of my jobs then on that program was to fact check the script, and one of the things that people kind of kept writing in the script, other producers, was the time on Mars is. And I kept pointing out that that's a silly thing to say. You know, Mars doesn't have a particular time. It's not like it's one place. It's a whole planet. It's like saying the time on Earth is. You know, it just doesn't make any sense. And they understood it when I explained it to them, and we corrected the scripts before broadcast. But actually, it made me realize there was a kind of big sort of more widespread public sort of flawed perception of what Mars actually was. And this became abundantly clear when the first pictures from Pathfinder started to come back. And there's a lovely panorama that some of you might remember of the Sojourner rover, I think, butting up against one of the first big basalt boulders that it explored. Was it called Yogi, I think? It's a long time ago now. I can't remember. Anyway, for me as a geologist, this was a really kind of thrilling landscape for Pathfinder to have dropped into, because here was this chaotic, massive rubble that had been sort of dumped there by quite a colossal outpouring, we thought, of water at the time, perhaps, that had flooded over this area perhaps 2 billion years ago, dumping all these rocks there. And there we were able to kind of go up and make some measurements of them all those billions of years later. How exciting. But for non-geologists, this was a sort of, another kind of red desert landscape that wasn't really much different from the other ones that they'd seen. Here's a couple from Viking days, and one eventually from Spirit that came back years later. And to the untrained eye, yes, they do all look like the same sort of desert that you might find perhaps on Earth. But for me, these were all sort of totally different places that I was just really kind of wowed by. So it got me thinking, how could I kind of correct that? Was there any way I could kind of figure out a way of sort of drawing people's attention to the fact that Mars was a really varied planet, a whole planet like the Earth? And I got thinking about the landing sites and started wondering where they were when I mapped them out. I never paid attention to exactly where they were spread out on Mars. And so I started thinking, well, is there a Martian coordinate system? I assumed NASA must have one. But it turned out actually two German astronomers, Wilhelm Beer and Johann Madler, had actually first worked on a system of latitudes and longitudes on Mars. They picked this rather prominent dark spot that they could see through their telescopes, Sinus Meridiani. And that was their prime meridian, their kind of Greenwich meridian, if you like. And their maps sort of followed that pattern. And in fact, this stuck when 40 years later, Giovanni Schiaparelli started mapping Mars. He picked the same meridian as they'd established to start making his maps of Mars as well. And so when NASA started landing there, firstly in the 70s and then through still as they're doing today, they of course adopted the same latitudes and longitudes. And there are, when I started this project, only 8 landing sites, obviously 9 now with Perseverance, but there are the landing sites spread across Mars. So I, a few years ago, started thinking, okay, well, I need to find the latitudes and longitudes of these, which I started doing. And then I started looking on Earth, where would they map onto in the same spot on Earth? And as you can see, you know, they span the whole planet. There's some up in the kind of polar regions, with Phoenix, of course, up here. And then plenty is sort of along the equator, and a few just towards the southern hemisphere, not quite, but almost there. But more significantly, look, they landed, three of them in the Atlantic there, one in the Pacific, another one off the coast of the Philippine Sea, and then these sort of three that were on land, one up in Canada, one in Siberia, and one in West Papua. So I thought, well, gosh, I need to have a look at the pictures from Mars and pictures of these places on Earth, and maybe I can compare them. So that's what I started doing. And so here's the first four. This one from Viking 1 with the matching spot in the mid-Atlantic. Viking 2 with its matching place in East Siberia. Number 3, or the third one rather, Mars Pathfinder in the mid-Atlantic. Then Spirit mapping onto the South Pacific. Opportunity to the South Atlantic, just south of West Africa there, as you saw on the map. And of course, Phoenix in northern Canada, Curiosity in West Papua, and then Insight near the Philippine Sea. Now, I have to say that the first thing that strikes you when you kind of toggle back and forwards between these images is that Earth is wet, well and truly wet. So there's three of them in those big ocean basins, and then the other ones all have a sign of water on them as well, whether it's these big river systems in the arboreal forests in Siberia and Canada, or in West Papua. There is water everywhere. But the other thing that struck me, again, when you toddle backwards and forwards between them, is that interestingly, there's not much in the way of signs of life on either planet. Of course, we're still searching on Mars for evidence even of microbial life. But here on Earth, I kind of thought, gosh, it's going to be teeming with life. And of course, there's life under the water there, sure enough, in these oceans. But there's nothing actually visibly there, in the same way that there isn't anything visibly alive on Mars in those pictures. When you get to eastern Siberia, of course, and northern Canada and West Papua, there's evidence of plants, but again, nothing that spectacular, and certainly no animal life. And then the other thing that struck me, of course, is that there's no humans here either. And so that was kind of a big surprise. During the last year of kind of lockdown, where we've been largely confined to these urban environments, it feels increasingly, particularly with stories about the Anthropocene and our rather dire effect on the world, that the whole planet is sort of teeming with us, and we're everywhere, and we've touched and somewhat adversely affected most environments on Earth. But here was evidence that of no humans, at least in sight. It was something that really did surprise me. In fact, so much so that I really struggled to get all of these images because they were from such remote locations. So I had to tap into a friend of mine, another geologist friend who works on survey ships and crosses big oceans, doing undersea surveys for cable laying. And he was able to share a couple of images with me from the mid-Atlantic, which came close to where these landing sites were on Mars. Then Google Maps helped me get a bit closer with some of the others, but they're not spot on. They're within the vicinity, sometimes many tens of miles away. So that was as close as I could get, really. And then the Philippine Sea one was just something illustrative that I could find of approximately that area again. So this was such a surprise that I hadn't really thought would be the case. I figured it was going to be much easier to get images of Earth than Mars, but in fact, the opposite was true. So what of Perseverance? Well, of course, I knew in advance that Perseverance was going to be touching down at this spot here, which would map onto an area about 100 kilometers north of Hyderabad in southern India. And I figured, well, gosh, you know, it's going to be, at least it's going to be a bit easier to get a photo of that spot, because it's a more populated region. There might be roads going there, and presumably a population living quite nearby. Or so I thought. But it wasn't until Perseverance touched down that we got exact coordinates, and I could get on with the job of trying to kind of find someone that might be able to take a photograph here. And so the weekend after it landed, I got on various NASA websites and tried to track down exactly where it was. There was a lovely image that was released of Perseverance itself, the descent stage, the parachute back shell, and the heat shield there. And so by zooming in on various different kind of maps, online maps of Mars, I was able to sort of pinpoint a pretty accurate latitude and longitude to within a few meters. So then I went to Google Maps again and tried to map that back onto this location in India, and sure enough, there it was, as predicted, 100 kilometers or so north of Hyderabad. In fact, right on the southern border of Maharashtra state and Telangana. That's pretty much where that dot is. So Wali is in Telangana state, and Gaon, is it? So maybe someone can correct my pronunciation of that. Is in Maharashtra. And so I thought, well, great. So I've now got my position. I just need to try and find a willing collaborator that can kind of head there. So the BBC picked up on this story, BBC World Service, and got me on their program Digital Planet. And it turned out one of their correspondents also lived in Telangana. So I thought, excellent, maybe we can get them up there quite quickly and maybe involve a local school. I found there was a school in Sawali that I thought maybe the kids could just walk a kilometer north, and there in the fields there, they could find this weird twin spot to Mars, and what fun that could be as they take a picture. But it turned out that the correspondent from Digital Planet was too far south, and the roads up to that area weren't good enough to get her to travel up there. So I reached out to this polytechnic that you can see there, the Rajiv Gandhi Polytechnic. So sadly, wasn't any way of contacting the Sawali school, but I got no replies from them. And then I thought, well, I've got lots of friends who have family in southern India here in the UK. So I tapped into them, and they asked friends and relatives, but that got us didn't get us any closer. But one of them suggested actually Astronomers Without Borders, which is why I'm here today. And so I wrote a kind of unsolicited email to you guys, and Zoe kindly wrote back and said, hey, this is a great project. We really love it. Let's see if we can help you. But since then, of course, the pandemic has really sort of taken on another aggressive and nasty chapter in India. And tragically, it's really a big problem there now. And that's really put a stop to any travel between states and any chance to kind of access people that could collaborate with us on the ground for now. So our photograph of the equivalent of Jezero crater here on Earth will just have to wait, I think. However, what these pictures and the pandemic to some extent really reminded me of was that, in fact, you know, as a geologist, I'm really aware of how indifferent planets are to any life forms that have evolved on their surfaces. And, you know, it's only really through a vast kind of coincidence of cosmic serendipity that Earth's natural life support systems have allowed humans to kind of flourish, to create civilizations like those that we've got in India today and elsewhere, of course, all over the Earth. And so the thing that these images, when you look at them, of Mars and Earth when juxtaposed together like this, really show us, in fact, is that, you know, we should never take Earth's habitability for granted. And I think with every new Martian vista that we get back from the red planet, it's really a reminder of that. And with that, I'm going to hand back to Andrew, and I hope I'm still connected to you all.
Thank you very much, Chris. That's fantastic. It's amazing seeing the two worlds together like that. I mean, it's just amazing the differences. And I think, looking at all the parallel at the same latitude and longitude positioning, what struck me was the amount of water. Yeah, I mean, the amount of water that we have here. You know, I mean, all these sites that you're you're transposing on back onto Earth the coordinates, they come up somewhere on an ocean, a sea or something. So it's I'm wondering, Chris. I mean, if we go back, we look at what the signs are pointing to on Mars. Many places on that planet show that there was running water. There are bodies of water, right? I mean, that it might have been much more Earth-like than we ever thought.
Yes, that's still the current theories which emerged early on in our exploration of Mars. That when you look at these fluvial features, my PhD was partly on fluvial geomorphology, and Mars is absolutely littered with examples that it would be pretty weird if they weren't carved out and formed by running water sometime in the past. But of course, as we all know today, the Martian atmosphere is a shadow of its former self, a shadow of what we've still got here on Earth. And without the right pressure, you lose ground heat quite fast, and you lose water. And I think, as I said at the end of the presentation there, that for me is a reminder entirely of the facts that, planets change. Opportunities and conditions for life to thrive on planets are not a guarantee. They're a quirk of cosmic serendipity, and they come and they go. And, you accelerate their demise and their decline at your peril as an intelligent technological civilization. And that's the situation we're in right now. And Mars is a great reminder of that, actually, when you think about it. I mean, I love looking at images that come back that previously no eyes have kind of laid sight on. And when a new image arrives, the first thing I think of is just wow. But then if you think more deeply about it, they're all, visceral reminders of what we have here and what we have to lose.
Yeah, I mean, it's amazing. Chris, I'd be remiss not to mention that we are getting questions from our viewers. And I want to get right into that. There are some interesting questions. Here's one question from Sarah. Sarah's asking more of a science question. Are the rocks on Mars igneous?
Well, hi, Sarah. Thanks for your question. Yes, the short answer is yes, they are igneous. So those rocks that Pathfinder went up and had a good look at all those years ago, back in 1997, they were all largely basalts, andesitic, I think is the phrase, andesites and basalts, and they were all extrusive igneous rocks with very tiny crystals in them that therefore show that the rocks cooled quite fast. And rocks that cooled fast usually cooled fast because they were extruded onto a planetary surface and then cooled down, rather than being trapped underground and turning into rocks perhaps more like granite, igneous rocks more like granite with bigger crystals that took longer to grow because the heat was conserved. So yeah, they are almost all igneous rocks. Now there's various other physical processes that have acted on those igneous rocks over the billions of years on Mars, which have laid down sedimentary rocks. And we hope, fingers crossed, one might have a fossil in it one day. So, although as the astrobiologist Chris McKay often says, it would take a corpse rather than a fossil to really kind of push the frontiers of astrobiology on Mars, so that you'd have a sample of something living, at least something you could extract a DNA sample of, to prove whether there was a new genesis event on Mars that wasn't related to a single genesis event upon which our entire tree of life on Earth has come from. So the great question is, are they going to be cousins on Mars that came from a common ancestry somehow in terms of amino acids and DNA, or is it a second genesis event? And that's hard to establish from a fossil, but hey, I'd settle for a fossil right now.
Yeah, exactly. Even a small little microbial fossil would be so historic, epic discovery. We have another question here from Raoul in Belgium. He's asking, do we have a precise idea of the colors our eyes, I guess us humans, would see on Mars?
Oh, well, that's a lovely question, Raoul. Thank you. Well, yes, you can often glimpse on the tops of the rovers when they land on Mars. There are these various color charts, that are calibrated to lighting conditions here on Earth. So we know exactly what kind of a red that red is and what kind of a blue that blue is on the color chart. And then essentially the camera, having been calibrated originally on Earth, then is turned on this color chart that's sitting on the surface, on the top of one of the surfaces of the spacecraft, and you get to see what those colors look like on Mars. So you can often see, obviously there's changes because the light's scattered differently. There's not the gases in the atmosphere to scatter the blue wavelengths on Mars. There's more dust that scatters the red wavelength, so everything's got more of a red hue to it, as you well know, probably. But that gives us a sense of what the human eye would see as well. And most of our images now are color corrected for what they would look like if a human was standing there. Interestingly, the first images from Viking, they assumed the sky would be blue, and they colored them blue. Before they realized their error. So, but now the images we get are more realistic to what we'd see if we were standing there. Yeah.
Well, I mean, I'm immediately thinking of movies. You know how movies represent when you see actors on Mars, right, as they show them, and what the colors are and everything. It's really interesting. And actually, Raul has a follow-up question, kind of more, I think, in the film industry. Like you could put that hat on now. Chris is working on film. Is Raul's asking, when will we see a movie with actors moving around Mars with 1/3 of gravity, like it should be?
Well, as a producer that's made movies that were supposed to be set on Mars, I know the challenge here. So quite a while ago for the BBC, I made a series called Space Odyssey: Voyage to the Planets. She was out around the world as well. Which was a sort of story where it came from the producers of Walking with Dinosaurs. In fact, it was the same team behind Walking with Dinosaurs, and our working title was Walking with Astronauts, I think, or something. So it became Space Odyssey later. Anyway, I was charged with exactly this task that you've asked, Raoul. I had to try and work out how we could create this one-third G environment for the film cameras, and we shot all of our Mars scenes in the Atacama Desert in Chile. And I remember spending quite some months trying to work out if we could use helium balloons to attach them to actors to carry 2/3 of their body mass, so that whenever they moved around, they would sort of feel lighter and bounce more lightly than they normally would. And we spent a lot of time doing some R&D on all of this, and we talked to people who'd also tried this. But in the end, it was so dangerous to do, because if the wind got up, you'd lose your actors. They'd just be blown away as the wind caught this huge helium balloon, that dirigible that was suspended above them, almost lifting them off the ground. So BBC Health and Safety just said, no way, you can't do that. So in the end, we sort of shot everybody but didn't film them running or moving, because that would have given it away. And we simulated it with really good CGI in the end. That was the only way we could achieve that. So yeah, it's not easy. I think in studios, you often put them on a rig that kind of lifts them off the ground a bit. And, there's some pretty good effects now that sort of make it feel like it's a reduced gravity environment in more recent Mars films. But it's not
Chris,
cheap. It's very expensive.
Chris, what's coming into my mind is I'm trying to imagine Matt Damon when he was on Martian with balloons stuck above him, carrying him around. That would have been quite a sight.
It would have been. I'm not sure the insurance would have covered that.
Well, let's move on for a couple more questions here. Suna is asking, could you please share your thoughts about this discovery of Mars, if this is groundbreaking chapter for several sectors such as mining in the world? So I guess Martian discoveries and their influence on different industries like mining, I guess. Could there be some influence on those sectors?
Well, it's an interesting question, because, of course, maybe what you're getting at, Suna, is that actually, if humans ever travel to other worlds, we've got to learn to live off the land, as it were. Just as, early settlers traveling to new worlds on Earth did. They couldn't possibly take everything they needed with them. So they had to learn to, harness the resources that they found. And so the trick, in either going to the moon and having to carry everything out of the gravity well. We live right now, we're all sitting in the deepest gravity well in the inner solar system, and it's a really expensive thing to climb out of. So the last thing you want to do in going to the moon or Mars is carry all the stuff that you need up that steep gravity well. It's ferociously costly in terms of thrust and propellant and money. So if you can get somewhere and find stuff that's useful, then that solves a lot of your problems. It could potentially even bring the costs of reaching Mars down so significantly as to make it possible. So so with the moon, it became well, could we mine the water ice that's there that we've sort of proved exists over the last couple of decades? You know, some billion tons of water ice at each pole on the moon. That would make for a heck of a lot of hydrogen and oxygen rocket fuel and water to drink and oxygen to breathe that we wouldn't need to carry off Earth. So the question with Mars is the material through the rocks, the minerals on Mars that we could also utilize in this way that means we don't need to carry tons of extra stuff from Earth? And the answer is, well, quite possibly yes. We need to do more work on the mineralogy and geology of the surface of Mars, and to prove we could perhaps harness the chemistry there to synthesize it into propellant for returning rockets, or in consumables like water and oxygen that we might be able to sort of avoid having to transport there as well. So that's, I think, what the current state of play is in terms of looking at mining opportunities on Mars, should we ever achieve what Musk's talking about and end up with a settlement there. I don't think at the moment it translates back into transforming the mining industry on Earth, but I think that's what your question maybe was about.
Yeah, definitely. I mean, more long-term implications there probably down the road. Byron has a question maybe a little related about those resources. Can any of the instruments aboard orbiters, Mars orbiters, determine how much liquid is below the surface?
Wow. Well, as far as I know, I don't think certainly on Perseverance or Curiosity or Spirit or Opportunity or Pathfinder, they carried anything that was ground penetrating enough to deeply look for signatures of, say, water ice, where you'd look for a sort of double reflectance off a layer of ice or something. And I could be wrong about that, so please correct me if any of you out there know for sure that that's not the case. I mean, with InSight, however, its sole purpose was researching the subsurface with its mole. So that was about using seismometry and Mars quakes and geophones to record the way that sound waves are reflected through the Martian crust, to work out what the structures are below. So if anything, that was probably our best hope for looking for those kinds of insights into Mars's sort of past and where the water has gone now. Because you're right to ask this. It's likely that as the atmosphere on Mars disappeared, and the temperatures dropped, the water would have gone underground and would be pretty permanently frozen there. And there is evidence, of course, seasonally, that perhaps temperatures in the deeper parts of Mars' surface with the most air pressure at certain times of year, that ice might just turn into a liquid phase of liquid water briefly and flow again before sinking back into the ground and freezing for the rest of the year. So yes, it's highly likely that's there and perhaps could be exploited by future human explorers. But we don't know enough about the water cycles and the hydrology of Mars yet, I don't think.
Yeah, but definitely the water was in the past and probably underground and frozen reservoirs, perhaps. Astronorm in the Philippines is asking, this is an interesting question about, I guess, the cameras and the differences in the cameras, what could be there. I don't know if you can speak to this. It's how does the spatial resolution of the expected images from the Ingenuity helicopter contrast or compare with what the rovers can take pictures of, especially, I guess, with geological data that they're looking at? I mean, how do the two cameras between the what's on the drone and what's on the rover? My expectation is that the drone camera is probably extremely small and primitive very simplistic compared to what the rover has. What do you think?
Yes, I think you're probably right, Andrew. I'm no expert on the resolution of the cameras on Perseverance or Ingenuity. However, I would agree that they're probably inferior. The best resolution cameras are going to be on the main rover because they take the most power for bigger chips, and so with Ingenuity it will be a poorer resolution. That said, I think it's probably still certainly acceptable to use for geology. And the reason I say that is actually that to do good geology, you need a couple of things. You need to kind of be standing there in the environment, or your cameras need to be there to take pictures or get a view of the rocks. And you need to do it at different times of day, so the shadows change, and you can see different forms of relief or layers. You can do a lot of sedimentary geology by just looking at imagery at different times of day. And getting above the ground and looking back down on it actually is hugely advantageous. Whenever I was mapping here on Earth, I was always trained to go up high and look back down to pick up sort of details I might have missed when I was in the thick of it down there. So getting up above Perseverance and looking back down on it, I don't know how high they're hoping to go with these first Ingenuity flights, but it can only help tease out even more details about the local geology there, which then will inform where they send Perseverance in the months ahead. Incredible when you think about it, isn't it, Andrew?
It's, I like I said, I'm looking so forward to seeing Ingenuity take those, aerial shots of seeing the rover down below it. And then, of course, hopefully there'll be forays much more farther afield from the rover over the course of the coming weeks and months. If they can get this the flight going and do it well, I think we're going to get some spectacular, even if the camera is a small little web camera type, because it weighs only 4 pounds, the whole helicopter. So there's not going to be too much room for sophisticated, camera equipment. But I think whatever we get from there will be historic. There's no doubt about that.
It's certainly going to be historic. I agree with you, and I think you've got to bear in mind bit rates as well as resolution
right.
with it, because it's transmitting this to the ground. Those transmitters and all take power, and power is always the hardest thing on a Mars mission, because as we talked about at the beginning, the temperatures are cold. That's not great for batteries, and it's only got the tiniest set of solar panels on the top of Ingenuity to recharge. So you want to keep bit rates low and flight time at a max.
Well, it's going to be cool to see how that works out. Well, let me see here. We've got a comment. This is, I guess, finalize here to wrap up from Kieran. Says that I am currently located in New Jersey, but my family is in Mumbai, India. And it says, it would be my pleasure if I can help you in any way, I guess, with your project, Chris. Feel free to contact me on LinkedIn, and there's a link there to this person's LinkedIn profile. So if there are people there that would love to help you in your project, Chris, maybe you can finally speak a little bit about that, of how people can help you.
Well, how absolutely fantastic. Thanks so much for thinking of this and how you might be able to help. I'm really thrilled to hear that. I'll get your details from Andrew after this, and I'll drop you a line. I mean, I would say that the best help I can get at the moment is trying to tap into someone who could probably who's in the vicinity already, because I don't want to put anybody in danger by having to travel them a long way interstate in India right now. It's really difficult moving around there, I think. But if someone knows someone who lives reasonably locally and could get there totally safely, then that would be absolutely thrilling. So I guess that's my first hope, really. And as you probably know, there's another Mars lander coming up in a few weeks' time, Tianwen-1, the Chinese lander, which I was hoping we might be able to also continue this collaboration and try and get another image. It's a busy year for Mars, as you well know. In fact, if you've got a moment, just let me just do another quick screen share.
You bet.
With you guys, and I'll show you what I found at Tianwen-1 when I had a look. So in fact, this is this is the location. If you map it back onto Earth, I mean, I don't know exactly where it's going to land, but roughly speaking, it coincidentally, given it's a Chinese lander, maps onto a location in southern China, in Guangzhou County, near Guilin, and that's the closest Google maps view of that location I could find, and it's not very near. It's probably tens of miles away. But as you can see, there's not much water, although it's probably through that archway. You might be able to see a few lakes and things. But again, not much evidence of life other than plants and trees, although there is a path there that sort of suggests a human presence. So anyway, when that comes around, Andrew, I'd say that any further help in reaching out to your friends and collaborators in China to get something from there as well would be wonderful.
That's fantastic. That's fantastic. And Chris, let me put out your website here. So it's in the comment section. So you can just click on the link in the comments. But Christopher Riley's website is www.chris-riley.net. And in there, you'll also find, we have another link in the comments specifically for the project page, Chris's project. So you can read up more about exactly what it's all about. As Chris has mentioned, if you have connections and people in these local areas, well, then this could be really, really helpful for completing the next phase of the project. This is so exciting. And who knows, Chris? I mean, there's so much traffic heading towards Mars, that you could keep this going. It could be sequels.
Yes, well, you'd hope it would be easy from this point on, wouldn't you? Because if there's a network of people with their phone cameras at the ready, we should be able to take a few more snaps faster than we've been able to so far. So fingers crossed. Yeah, busy time on Mars, and that's only good for the human species, I think.
I do agree. That is really, speaks something to humanity. It's so inspirational, and we need inspiration now these days, especially. I think it's very important. So
I couldn't agree more. It's a good antidote to lockdown, looking at other worlds, isn't it? I heartily agree.
Exactly. Well, Chris, thank you so much for joining us. This has been absolutely a pure pleasure for us here at Astronomers Without Borders to have you and your and give a showcase to this wonderful project that you have between our two worlds. It kind of speaks to what we say is one people, one sky here at AWB, and it's one people and one solar system. I think, and that we're really speaks to that. So Chris, thank you, and please do stay in touch, and we want to hear how this project goes, and of course when your film is released, we'd love to hear it, and we'll definitely help spread the word.
Wonderful. Thanks so much again, Andrew. It's been great collaborating with you. I hope it's a long and fruitful project that we can put together. Thank you.
Awesome stuff. Take care, Chris. Bye-bye.
Bye.
So this has been fantastic. Thank you so much for all of you joining us wherever you are around the world. Again, if this is Global Astronomy Month, this is a special Facebook Live in honor of Global Astronomy Month, 12th edition. If you haven't yet been to our website to see the calendar of events, of upcoming specials, check it out. We've got it right below here. It's gam-awb.org. It'll take you straight to our calendar for all the GAM events held throughout this month. Don't forget, this weekend is a Global Star Party, where we'll have a special, hopefully if skies are clear, we will have a robotic online tour of the night sky, thanks to the Virtual Telescope Project, another longtime partner of AWB. And we're also asking you to participate in our Beauty Without Borders photo campaign, taking a picture of the Mars-Moon conjunction. All of that information in the comment section below. So I'd like to thank you so much. Hope you stay safe and healthy. And until next time, clear skies. Bye-bye.
उसके चेक 2 सितारों तक हम एक है, एक कौम, एक आसमान।
From the pale blue dot to the distant stars, we are one. One people, one sky.